Hi everyone. In this lecture, which means lecture 2, I will talk about complex numbers or imaginary numbers. But before that, let me do this 2 examples, which are word problems, because your Alex homework, they do have some questions similar to this. Therefore, I decided to show you these 2 examples here. All right. So suppose we have such word problem. So this word problem, it has 2 variables. It says solving a word problem with 2 unknowns using a linear equation. So when we solve a word problem, the first thing that we need to do is we need to understand the question correctly, and then we define variables. For example, you can use x and y. So let's say x. Now this one says a total of 369 tickets were sold for the school play. They were either adult ticket or student tickets. So we have 2 types of tickets. So let's call this x to be the adult ticket. And the other one, let's call it y. Okay. And then the total from the first sentence, a total of 369. So when we add these 2, this is number of adult tickets, this is number of student tickets. So when we add the 2 tickets, 2 type of tickets, the total sold, then we get x plus y. This is the total number of adult tickets sold, and this is the total number of student tickets sold. And when we add them up, we get 369. Okay, and then let's go to the next sentence. The number of student tickets sold was 2 times the number of adult tickets sold. So number of student tickets sold is y. Let me put sold here. So based on the third sentence, it says y equals to 2 times the number of adult tickets, which is x. So we have one equation and the second equation. So we have 2 equations. And we have to, if we remember how to solve simultaneous equations, then we can use substitution or elimination. So if I substitute this one in equation 1, we substitute 2x in place of y. So we get x plus, instead of y now I will put 2x equals to 369. Now we add this because they are like terms. Both of them, they have x. Therefore, this becomes 3x. And if you remember this from lecture 1, in order to solve for x, we need to multiply both sides by a number that makes this one 1, the coefficient of x 1. So to make the coefficient of 1, we multiply both sides by 1/3. And they cancel out on the left side. So we have just x. And here, if you divide 369 by 3, you get 123. So this is the total number of adult tickets sold. Okay. Then how about the students' tickets? Well, we can just use this formula, this equation. So y equals to 2x, and this is 2 times x. We found it already. We plug that number here, and we get 246. And this is the number of student tickets sold. Okay. So this is how we solve a word problem in two variables. So always, once you convert the word problem into equations, then from that we just use algebra. So the main thing is understanding the question, the problem, and then writing it into equations. All right. And the other type of word problem is just distance, relationship between distance, rate or speed, and time. So here we have the construction crew has just built a new road, and this is a formula. Distance equals to rate times time. So here we will use this formula. Okay. Therefore, what given bodies do we have? It says the distance is 7.68 kilometers. They built this much, and the rate is R 6 kilometers per week. In 1 week, they built 6 kilometers. Now, how many weeks did it take them to build all this 7.68? So we need to find T, the time. And this time is not in hours, it is in weeks, because this is given in weeks. Okay. Therefore, I will use the formula, just write the formula. And we know D and R are known, but this guy is unknown. So I have to solve for T. And to solve for T, what we do is we divide both sides by, or we multiply both sides by 1 over R. So on the left side, I have D over R. On the right side, they will cancel out. So we will have just T. So T is D over R. Therefore, if we substitute those values in here, we have T equals to body of D is 7.68 kilometer, and R is 6 kilometer per week. So this will cancel out. And if we divide 7.68 by 6, let me see. 7.68 divided by 6, and this is 1.28 weeks. Okay, 1 full week and a few days. Okay. All right, so this is solving word problem, different types of word problems. So in this lecture, we we showed only 2 of them, but there are different types of word problems. There is other types. So maybe if you see different type of question different than this in your Alex homework, then if this can help you solve those, then that's good. If not, you can ask me the question. I will explain to you. All right. Now, here we will talk about complex numbers, but before that, we need to address what an imaginary number is, because this is the building block of a complex number. Now, first, why do we need an imaginary number? Because we don't use them in our daily life. We just count 1, 2, 3, right? Those, we probably would say those numbers are good enough for us to survive, right? But in theory, in mathematics, for example, in order to solve this one, I mean, if I have x squared equals to 1, then what is x? X will be either 1 or -1, because 1 square is 1, -1 square is 1, right? So if x is 1, then 1 square is 1. If x is -1, then -1 square is 1. So x could be 1 or -1. And then the question comes, how about if I have x squared equals to -1? Okay, what happens for this one? Well, That's the big question now. If we didn't have these complex numbers or imaginary numbers, then there is no answer for this one, right? Because there is no solution, a real valid solution for this one. And probably you have learned this one in high school or something. No real value solution. Okay, this is important. We're talking only about real numbers. So for this, there is no real number that makes this one true. If you take any real number, then you can never find any real number that makes this one true. So in order to answer this question, mathematicians, they introduce this imaginary numbers. Okay, so what is an imaginary number now? An imaginary number is a number which is represented by I or with some coefficient, and I is just the square root of -1. Okay, this is an imaginary number. So I equals to -1, and if we square both sides, then I squared is -1. Here I equals to root -1, and I squared equals to -1, because if you square both sides, you get this one. Okay, so this is what this is how it starts. This is the building block of an imaginary number or a complex number, and this is an imaginary number itself. Okay, and if I have a positive real number b, let's say b is a positive real number, then square root of -b, square root of -b, I can write this one as square root of -1 times b inside the square root, right? I can just put 1 here because -1 means -1 times b means -b. And then I can write this one as square root of -1 times square root of b. Okay, b is a real number, so I don't have any problem writing it this way. Now, what is this first term? Well, based on this definition, this first term is just I, because if you see, the first one is square root of -1, which is I. And if I replace this one by I get I square root of b, which is this one. Therefore, square root of -b, if the negative is inside, be careful, this negative has to be inside of the square root. So if we have square root of negative a number, then that's the same with you remove the negative, put I in front of the square root, and then put square root of the real number b. Okay, b by itself is a real number, but when combined with this I, it becomes imaginary. This is still imaginary altogether. Now let's look at some imaginary numbers now. Okay, so writing imaginary numbers in terms of I, as you can see, these numbers, they have negative inside the square root. And if we have square root negative inside the square root, as I mentioned earlier, these kind of numbers, they don't have any, I mean, they are not real numbers. These are not real numbers. Okay, so if we were dealing with real numbers only, then we would have avoided this. We would have ignored this one. Okay, but in this case, now we are introducing a new group of numbers, which are called the imaginary numbers, and combined with the real numbers, they make up the complex numbers. Now let's write this one in terms of I. Okay, so this, let's write this one as -1 times 81, and this is, well, I don't have to. Okay, let me just finish this one and then I will skip the steps. Okay, and then this is square root of -1 times square root of 81. You can straight use this definition, this explanation, because we have it already here, but just to for you to understand it better, I'm just repeating the same step. Now the first term here, This is I, and square root of 81. Now this one is a real number, so you can find the square root if it has a definite square root. And the square root of 81 is 9. Therefore, I have I times 9. Okay, and we write this one as 9I. Okay, you bring the real number in front and the I after. But if you have square root, you bring the I front usually, because it's confusing. Because, for example, if I put like if I write square root of 3 times I, you may get confused, like, is the I inside or it's outside? Okay, you may not be sure. So what you do is you write it this way. Okay, but if you don't have square root, we write it this way. Okay. Now, how about the second one, square root of negative 50? So here b is negative 50, and we have negative here. So this is just square root of negative 1 times square root of 50, and this is I times square root of 50. And you can simplify this one further, because 50 is 25 times 2, right? And 25 is a perfect square. So you will have square root of this one, I times 5 square root of 2. Okay, because square root of this one is 5. And then here, square root of negative 11 is just I square root of 11. 11 is not a perfect square. Okay. All right. And then simplifying expressions in terms of I. Now this is multiplying two imaginary numbers, but in this case they don't have I, so we have to simplify this one and put the I there. Okay. Now first, what we do is we write this one in terms of I, each of them. Okay, because this is product of this one and this one. Now you have to be careful here. Okay, so the first one is I square root of 16 times the second one is I square root of 7. Okay, oh, sorry, 49. And this is I square root of 16 is 4, so I will write it 4I. And square root of 49 is 7, so I will write it 7I. Now the product of this one, you just multiply the numbers, the real numbers. So it will be 28, and then I square. Okay. Now the question is, what is I square? What is I square? Well, if we go back to the definition, we have I square here. I square equals -1, which is a real number. It's not imaginary anymore now. Okay. Therefore, instead of I square, we put -1, and 28 times -1 is just -28, which is a real number. So multiplying two imaginary numbers, we get a real number. Well, it's a negative, but still it's a real number. And here we do the same thing. So this will be I root 10 times I root 2. Now you multiply both the real numbers and the i's. So we have I square root 10 times root 2. Again, I square is -1, so I will put -1. And this one, you can put them under one square root, 10 times 2. And this is -1 square root of 20. And this is -4 times 5, right? I'm still simplifying it because here 4 is a perfect square root, perfect square. So this will be 2 square root of 5. Okay, so this is the simplest form that we can get. So always try to simplify your answer. Still, this one and this one are the same, but this is the simplified form. Instead of saying square root of negative square root of 20, it's better to say negative 2 square root 5. Write the simplified form always. So what I wanted to say here is that this is a kind of warning. So here for real numbers, square root of a times square root of b is the same with square root of ab. Okay, this is true for real numbers, a and b. But for imaginary numbers, square root of a times square root of b, negative b, these are imaginary numbers, may not be square root of negative a, negative b. Okay, so do not combine them, do not put them in under one radical. Okay, do not use this property for this thing. So what we do is always convert this one to write this one in terms of I, and then after that you can use this property. Okay, after getting rid of this negative number, then you can get this one. So this is because this is not equal, this is not the same. Okay, therefore you have to be careful in this when you multiply or divide imaginary numbers. Okay, coming back to this. So again, we write this one in imaginary number in terms of I. So that's negative, this is I square root of 48 over I square root of 3. And well, we have two i's here, they will cancel each other. And we have square root of 48 over 3. Okay, and this is square root of 16, and this is just 4. Because these i's, they cancel each other. We have on the numerator and denominator side. Okay. Okay. Now we go to the bigger number, the complex numbers. So the imaginary numbers are just a building block. So what is a complex number? Well, a complex number is an imaginary numbers plus the real numbers. So we know what real numbers are, all the real numbers. If you add or if you include the imaginary numbers with the real numbers, then we make up the complex numbers. And a complex number is written in the form of a plus bi. This is how we write a complex number. This a and b, they are real numbers, but the b is multiplied by I. There is an I here. So this term is called the imaginary term. And this term is the real term, or real number. Okay. So a complex number is a combination of real number and an imaginary number. Now, what happens if b is 0? Because 0 is a real number, right? So if I replace b by 0, then I will have 0 times I, which is 0. So, and we have a plus 0, which is a. And a is real number. Therefore, when if b is 0, then a plus bi is just a, which is real number. Okay, which means all real numbers, they are complex numbers. They can be written in this form. Okay, for example, if you have 3 is just 3 plus 0 times I, because this is still 0. So I can write it this form in a standard form, for example, like this one. I can write it this way. So still this format is a complex number format. Therefore, all real numbers are complex numbers. And how about if a is 0? If a is 0, we have a plus bi, which is, this is 0. So it will be bi. And this is pure imaginary. imaginary number. Okay, there is no real number part in it. Okay, and the standard form of a complex number is this. So when you are asked to write a complex number in its standard form, this is what we call the standard form. Okay, for example, we have this one, and we are asked to write this one in its standard form. So the first thing that we need to do is we write this one in terms of I, and then we rewrite it, okay, so that it will have the standard form. So here I have 4. Now, how do we write this one in terms of I? Well, this is I times square root of 49, and 4 plus I, this is 7. Okay, so I have to rewrite this one now. I said earlier, I mentioned when you have square root, the I will be on the front side. But when there is no square root, or when there is no radical, then you bring the number in front. So this becomes 4 plus 7i. And this is RA, this is RB, and this is the standard form. And again, here we have a division. So to write this one in standard form, we don't have square root, we already have the I, so we don't have to worry about that, but just the fraction of the number. Instead of putting both of them, having both one denominator, we split the denominator, and that will be 3 over 7 minus 8 over 7 times I. And that's it, okay? Because we cannot simplify this one further. Again, here we have both of them. We have to write this one in standard form, in the form of I, or in terms of I, and then write it in standard form. So I will do both at the same time. 10 over 20 plus the top is I square root of 75, and 75 is 25 times 5, right, over 20. So 10 over 20 is 1/2. We have I, and this is square root of 25 is 5. So I will have 5 over 20 square root of 5. And we can simplify this one. And that becomes 1/2. This is 1 over 4. I square root of 5 over 4. Okay. So yeah, so that I think just to avoid confusion, because earlier I was saying, like, when you have square root, it's better to write I in the front side, but I guess that will be confusing. So you just have to be careful when you write it, but let me write it this way. Square root of I over 4 times I. So let's just put it the standard form, all of them. Okay, so write it this way. Just whether you have square root or not, bring the I in front at the end. Okay, going to the next. Now performing operations on complex numbers, like adding, subtracting, dividing, and multiplying complex numbers. But before that, let's look at this. If you have powers of I, how do you simplify this? Or what is this now? I, we know I is square root of -1. But if I have I to the power of 13, I to the power of 103, I to the power of 64, then what does that mean? Right? So to do this, to simplify this. Let me start with now we know I is negative root 1. Sorry, I is root negative 1, and I squared is negative 1. How about I cube? I cube is I squared times I, right? And I squared is negative 1, and I is this guy, right? So just I will keep I. Therefore, this is negative I. So I cube is negative I. We have I, just ignore this one. We have I squared, which is negative 1, and I cube, which is negative I, and then I to the power of 4. I to the 4th is I squared times I squared. I can split this one into 2. And I squared, I know it's negative 1, so I will replace that one by negative 1, negative 1. Negative 1 times negative 1 is positive 1. So we have 4 different values now. I squared, which is negative 1, I cube negative 1, negative I, and I to the power of 4, positive 1. Now what happens if I continue now? How about I to the 5th? This is I to the 4th times I. We can split this one. If you remember how to write power of exponents, we can write this one in this form. I to the power of 4 is 1. So I can write 1 times I, which is 1, I. So this one is the same with this. I to the 5th is the same with I. How about I to the 6th? Again, this is I to the 4th times I to the 2nd, and this is 1 times I squared. Sorry. And I squared is negative 1, so just negative 1. Again, I to the power of 6 is the same with this one. And I to the 7th is I to the power of 4 times I cube. I to the power of 4 is 1. I to the power of 3 is negative I. And again, this is negative I. And I to the power of 8 is I to the power of 8. 4, I to the power of 4, which is 1 times 1, 1. Okay, and this continues. It will continue the same. So these are the only numbers that we have. All the powers, they can be simplified into either of this. Okay, therefore, what do we do now? So always what you do is you write the exponent in terms of power of 4, okay, plus something. For example, what I mean by this is, let's go to the example. Let's say we have this one now. Now, what is the number smaller than 13 which can divide 4 without remainder? Well, it's 12, right? So I can write this one as I to the power of 12 okay. Let me write it this way. Okay. Times I to the power of 1. Okay. Now, this one, as you can see, all the numbers that divide 4, they have the same, they are equal. For example, here, if you see I to the power of 4 is 1, I to the power of 8 is 1, I to the power of 12 is 1, I to the power of 16 is 1, I to the power of 20 is 1, and so on. Therefore, using that property, I just try to find the smallest, the largest number, which is smaller than 13, that divides 4 without remainder, and that's 12. So I know this one is 1. I don't have to repeat all those steps now. So this is 1, and here I have I, therefore this is just I. So I to the power of 13 is just I. And similarly here, what is the largest number that divides 4 without remainder that's smaller than 103? Well, we know 100 divides 4 is 25, right? So I will write this one as I to the power of 100 times I to the power of 3, right? Sum of those. Now this is just 1 because of that same property, and I cube is negative I from the previous steps or properties, and this is just negative I. And I to the power of 64, well, we know 64 divides 4 without remainder, therefore this is just 1, because 64, well, you can simplify this one if you don't remember the properties. What you could do is you can write this one as, simplify this one as 64 is 4 to the power of 4 to the power of 4. But anyway, you can distribute this one if you, of course, it will be too long. It will take time, but you can write this one as, you can split it as 32 times I 32, and this is I 16, I 16, and so on and so forth. So you can go down to 4, and that way you can simplify it. Okay, but there is no need, because now we have the property. If the number divides 4 without remainder, then it's just 1. And how about this one now? So this is I to the power of negative 30. And this is the same with 1 over I to the power of 30. Okay, we have this property. If the exponent is negative, then when you take the reciprocal, it becomes positive. So this is the same with this one. Now we can change this one. We can rewrite this one in terms of, we can simplify it. Therefore, that becomes 1 over. Now, what is the smallest number? The number which is smaller than this one that divides 4 without remainder. It should be 28. 28 times 7. Okay. So we have 28 times I to the power of 2, and this wait, yes, yeah, 7. So this one again is 1, and this one is, if you remember, negative 1. Therefore, this is just negative 1. Okay. So anyway, once you remember this, these are the main things that you need here. This 4. Okay. So always look for this one, because this is the largest number. So if you have, let's say, I to the power of 204, well, you check if this divides 4 without remainder. If it doesn't, try to find the number which is smaller than this one, but divides 4 without remainder. Okay. Let me make it like 5. So we know this one doesn't divide 4. So I have to write this one as 204 plus 1. Okay. So this one divides 4 without remainder, but this one doesn't. So this one, I to the power of this one, I to the power of this one, and this is a 1, and that's just I. Okay. Therefore, I to the power of 205 is just I. You don't have to distribute all those list one by one. Okay. Now let's go to adding and subtracting complex numbers. So if you have two complex numbers, let's say a plus bi plus c plus di. So this addition could be subtraction, doesn't make any difference. Still the same applies. So this is the same with what we do is we add, well, with subtraction we have to use the distribution, by the way. So we add the real numbers. So here we have a and b, they are real, and the imaginary is this one. So the real numbers will be a plus c, and here we have bi plus di, and here we factor I out, so it becomes a plus c plus b plus di. Okay, so this is how we add. And with subtraction, it's the same. We distribute the subtraction, this minus, to both of them. So this becomes a minus c, because minus c, which will be, and this one will be minus di, plus, what is it? Plus bi minus di, and this is a minus c plus b minus d times I. So this is how we add or subtract complex numbers. So always you add or subtract the same terms, the imaginary with imaginary and the real with real number. For example, here we have this example. And to add this, well, from the first one, we have 8 as a real number. And from the second one, we have minus 2. So we have to take this, distribute this one to this 2 into the 2. And we have plus 5. And from the first term, the imaginary number is negative I. And from this one is negative 4i. And from this one is positive 7i. And then we just add this one, and we get 11 plus, and here we have negative 3i minus 4i, this is 7i, negative 7i plus 7i, this is 0. So we have just 11. And from the second question, so here we have fractions, and we just use the fraction property to add numbers. Other than that, there is no big difference. So this is 3 over 6 minus 1 over 10 plus 5 over 6 minus 1 over 3 times I. So we find the LCD for this one, and it should be 60. Well, we have 30. 30 is, yeah, we have 30. So this will be 515. Okay. Multiply both sides by to make this one. Okay, let me. So how we can do this is there could be different ways, of course. One thing is you make this one 30 by multiplying by 5 over 5, and this one by 3 over 3. And another way is you can put the 30 here. 30 divided by 6 is 5. 5 times 3 is 15. 30 divided by 10 is 3. 3 times 1 is 3. And we do the same thing here. From this one, because 6 is the LCD, so that way I have 5 minus 2 over 6 times I. And we have 12 over 30 plus 3 over 6i. 12 over 30 is 2 over 5 plus 1 over 2. Okay, and then multiplying complex numbers, and at the end we will see how to divide complex numbers. So with multiplying complex numbers, it's just similar to polynomials. We distribute whatever is multiplied into the parentheses. Okay. So for example, with multi polynomials, yeah. Okay. So here we have two complex numbers. We have -1/3i times this number. So what we do is we just distribute this one. This one times 9, this one times this one. Now we don't care whether we are multiplying it by a real number by imaginary, or imaginary by imaginary. We just distribute it as long as we have the parentheses. So this one times this one is times 9 minus 1/3i times -15i. And this one, they will cancel out. So we have by 3, we have 3. So this is -3i plus here we have negative times negative, so it becomes positive. 15 divided by 3, it's 5. I times I is I squared. Okay, and this is -3i plus 5 times -1, because I squared is -1. So this is 3i minus 5. Now I have to write this one in standard form. So the standard form of this one is -5 minus 3i. I bring the real number in front. Okay. And for this one, we distribute this, multiply this by this one. -5 times 3 is -15. Multiply this by this, plus -5 times -i. Multiply this by this, plus 4i times 3, plus multiply this by this one, 4i times minus I, -5. So I have -15, -15, and here we have negative times negative, it becomes positive. 5 times I is just 5i. Here we have 4i times 3, so it will be 12i. And here we have 4i times -i, it becomes -4i squared. Okay, now I have -15. Now we can add this one because they are the same. They both have I, so we can add them, and they are 17i. And how about this? What is I squared? Well, I squared is -1, so I can replace I squared by -1, okay, because it's a real number. And this is -15 plus 17i plus 4. Now we have two real numbers, so we can add these two or subtract. And well, 15 minus 4 is 11, so that's -11. Therefore, this is -11 plus 17i, and this is the standard form. Okay. All right, and here I put some more examples. And the reason why I put this one is because it's a bit special. Now, remember from polynomials, if we have if we have a plus or minus b, this is square. This is a square plus or minus 2ab plus b square. We know this one, right? And we know a plus b times a minus b is a square minus b square. We have this property, so we can just use this property to multiply two complex numbers. So in this case, these two are called conjugates. Okay, if you have something like this, a plus b times a minus b, if the second term has opposite signs, then we call it conjugate. This is when they are real numbers. And when we come to complex numbers, a plus bi and a minus bi are complex conjugates. And the product of complex conjugates is always a real number. Okay, always if you multiply two conjugates, complex in conjugates, then the product is a real number. Now let me show you this one. So using the property, the first property, this one is 4 minus 7i squared, and that's 4 squared, which is 16, minus, because this is a minus, 2 times 4 times 7i plus 7i squared. We have 16 minus, if we multiply this, is 28, 54i plus 49i squared. And this is 16 minus 54i. Oops. Okay, sorry about that. And this is 49. I squared is -1, so this becomes just -1. So we can replace this one. Now we have two real numbers, so we can subtract this 49 minus 16, and that would be 33 minus 54. Okay, all right. So we do the same thing with this one. You can either distribute it or you can use the conjugate property, and the conjugate property for this one gives us this is 10 squared minus 3i squared, just by the property. You don't have to distribute it. And this is 100 minus, and this one is 9i squared. 100 minus 9i squared again is -1. So -9 times -1, they become positive, and this is 109. Okay, so it's important to use or to understand the property so that you can apply. You don't have to waste your time. And the last one is dividing complex numbers. So when you divide complex numbers, what we do is we multiply the denominator by its conjugate, so that you don't have any complex number on the denominator side. We don't want complex. We don't want to see the I on the denominator side. So to get rid of this one, as you can see from this example above, when you multiply two numbers, two conjugate numbers, always you get a real number. It doesn't matter whether it's negative or positive, but you get always a positive number, real number, sorry. So since that's the case, you multiply both sides by the conjugate of the denominator. And the conjugate of this denominator is 2. You just change the sign of this term. If it's negative, put positive. If it's positive, put negative. Okay, this is the conjugate of this one. And you have to multiply the numerator by the same number. And then you just apply the distribution property. Okay, so the multiplication for the top is 10, 5 times 7 is 35i. 6i times 2, 12i. 6i times 7i is 6 times 7 is 42. 42i squared divided by, and this one we know it's positive, right? We know this is a real number, not positive. This is a real number. So here we have 2 squared, which is 4, and that one, if you take this, will be plus 49. And here we have, what do we have here? This would be negative 42, negative 42. This is negative 32 plus 47i over 53. And this is negative 32 over 53 plus 47 over 53i. And this is the standard form. And for this one, you got 5 plus square root of 7i to the power of negative 1, and you have to rewrite this one. So this is 1 over 5 plus square root of 7i. Now multiply both sides by the conjugate of this. And then on the numerator side, we have 5 square root of 7i. And on the denominator side, when you multiply to conjugates, you get 25, and that is plus 7. And here we have 5 over 33 minus root 7 over, it has to be 2, 32i. Okay. And how about this one now? What is the complex conjugate of this one? Well, the complex conjugate of this one is just negative 10i. Okay. And here we have 10i. So this becomes positive 70i, and that one is 100. So this is just 7 over 10. Okay. All right. So this is all for today, and see you in the next lecture.